Hello everyone, welcome back to the lecture series on ESP32. In the last lecture we saw binary semaphore demo. In today's lecture we will see counting semaphore. A counting semaphore is a synchronization mechanism used to manage access to a limited number of identical resources in a multitasking system. It maintains a counter that represents the number of available resources. When a task takes the semaphore, the counter decreases, and when it reaches it, the counter increases. If the counter becomes 0, additional tasks requiring the resource will block until a resource becomes available. Let us understand it using a parking lot and car example. Here, the parking lot are the resource and the cars are the tasks that take up this resource. So initially we have 3 parking lots, means we have 3 resources and 5 tasks utilize this resource. At the beginning, all the 3 resources are vacant, all the 3 parking lots are vacant. So car 1 takes up one of the resource, then car 2 takes up the resource. The semaphore count is coming down. Now only 1 resource is available. The car 3 takes up the resource. The 2 tasks are waiting in the blocked state. Since all these semaphores are over, all the resources are over, the semaphore count is 0. Next, car 1 finishes its works and vacates the parking lot. So now 1 resource is available again. So car 4 takes up the parking lot. Now again all the parking lots are full. The semaphore count is 0. 2 tasks, 2 cars are waiting for the parking lot. So again, car 2 finishes its work and vacates the parking lot. Now, car 5 takes up the resource. Again, car 3 finishes its work and frees the resource. Now, semaphore count is 1. So again, car 1 will take up the resource. Now, 2 of the car finishes its work and vacate the parking lot. So now, 2 of the tasks take up the resource. So like this, a counting semaphore maintains a number of counts of the resource, resource, and allots it to the task. This is a resource synchronization mechanism. So now let us implement car and parking lot example. Open Visual Studio Code. Then ESP Then new project wizard. ESP version 6. Hello World template. Create project using template. Enter the project directory. Enter project name. Module 2, Lecture 7, Part 4. Create project. Open project. Close the older window. Rename the CMain file. Name it appropriately. I will name it parking lot demo. Parking lot demo.c. We need to change the CMake list file. The name is already changed. delete the older content, include header files as include stdio.h, then include FreeRTOS.h, till task.h, then include Semaphore.h. Semaphore.h. Now we will make a semaphore handle. Semaphore handle, parking lot. Now we will make the task entry function for the car that will take up the resource parking lot. Void pointer as parameter. We will make 5 tasks using this task entry function, and we will pass car ID to this task entry function. So to receive that, we will make an integer variable, and we will cast the pointer directly to int. So here if you see void pointer, I am directly casting it to int. Actually it is not correct, but how we pass the parameter, it matters. First let us create a main function and then I will explain why I am casting it directly to int. As many of the places you will see this, because we can cast an integer to void pointer and that pointer value we will directly cast it to int, and many places you will see this. So I am using this way. Usually what we do, we will cast it to int pointer and then take the value out of it. So let us create the main function. We will create the parking lot semaphore. Create counting semaphore. xSemaphoreCreateCounting. So first argument is the maximum number of resources that we are going to create. We will create 3 parking lots, and initially all the parking lots are vacant. So we will put 3 here. If we put 0, then initially all the resources will be. Now we will create 5 car tasks. X task create pinned to core. Task entry function car task. A descriptive name to the task. Stack depth 2 kilobyte. Now here we will cast directly an integer value 1 to void pointer. So that's why when we are receiving this pointer, we are casting it directly to int. This is one of the way of passing. But if we start using this parameter as a normal pointer, then we will have issues. But since we are passing it here directly and we know that, so we won't use it like a normal pointer. So it won't cause any problem. Then priority 1. Then we won't have any handle to the task. So null. Then running on core 1. Similarly, we will create 5 tasks. task 3, car 3, car 4, car 5. Top 3, 4, 5. So now we have 5 car tasks and 3 parking lots. Initially, all the 3 parking lots are vacant. Let us make the task entry function. Infinite loop for the task entry function. So when this task starts execution, we will print the statement car arriving at parking lot. Car ID arriving at parking lot. Car ID. Once it comes to the parking lot, the car will try to occupy a parking lot. So it will take a semaphore. xSemaphoreTake. It will take up the parking lot. The task will be blocked indefinitely until the parking lot is available. Port max delay. This will block the task indefinitely. Now suppose the parking lot is available and the car is able to take up the resource. So we will say the car parked. Car ID. Now let us keep the car in the parking lot for some time so that we can visualize it. Five seconds. So we will just delay it here. We task delay TDMS to tick. Delay for 5 seconds. After waiting for 5 seconds, the car will leave the parking lot. So let us print a statement leaving the parking lot. ID parking lot car ID. Then release the parking lot using SemaphOreGive. Give up the parking lot semaphore. Before coming back, the car will wait for 3 seconds. So we will delay for 3 seconds. For 3 seconds. Save it. We will build the project. Now flash it to the device. Now monitor the output. So car 3 arriving at parking lot, car 2 arriving at parking lot, car 2 parked, car 4 parked, car 3 parked, car 1 arriving at parking lot, car 5 arriving at parking lot. Let us pause the monitor. So car 3 arriving at parking lot, car 2 arriving at parking lot. The parking lot was free, so car 2 got parked. And car 4 arriving at parking lot, car 4 parked, car 1 arriving at parking lot, car 5 arriving at parking lot, car 3 parked. Then car 2 leaving and car 4 leaving. So car 1 got parked and car 5 got parked. So like this the resource is being utilized. So in counting semaphore, an integer count of the resource is maintained, and as it is utilized, the count is decreased, and when it is freed, the count increases, and when the count is 0, the task waits for other tasks to give up the semaphore. So that's all from this lecture. See you in the next lecture. Thank you.